Friends, welcome to the online classes of chemistry. So, today we will discuss about ideal and non-ideal solutions. So, ideal and non-ideal solutions. Here, it carries near about 2 marks or 3 marks. They ask the question, what is ideal solution or what is non-ideal solution, or distinguish between ideal and non-ideal solutions. And here it carries 2 marks or 3 marks. So, here it is a compulsory question in solutions. So, here what is ideal solution? So, look here students, first one, what is ideal solution? Or they may ask define ideal solution, or they may ask write the characteristic properties of ideal solutions. So, what are ideal solutions? So, here ideal and non-ideal solutions in liquids or in liquid solutions. So, the ideal solutions here, the solutions are classified into two types. One is that is ideal solution and another one is non-ideal solution. It is based on Raoult's law. So, remember students, liquid solutions are mainly classified into two types, ideal and non-ideal solution. It is based on Raoult's law. So, here what are ideal solutions? The ideal solutions are those which obeys Raoult's law at all concentration range are called as ideal solution. So, here the ideal solutions are those which obey Raoult's law at all concentration range, are called as ideal solutions. Ideal solutions are those which obeys Raoult's law at all concentration range, are called as ideal solution, and these can be also mathematically expressed as P total is equal to, so P1 naught x1 plus P2 naught x2, as already we know that according to the Raoult's law. So, these are called as ideal solutions. And students, here why these are called as ideal solutions, and what happens to the ideal solution when the two solutions are mixed, means that is liquid solutions. One may be solute, one may be considered as solute and another may be considered as a solvent. So, what happens? So, here what are the properties? So, look here, what are the characteristics? Characteristics of ideal solutions. So, students, here when two liquid components, means that is if you consider that is one solute and another one is solvent, in case of ideal solution, number one, in case of ideal solutions, when two components A and B are mixed, so there is no change in enthalpy. Heat is neither absorbed nor evolved. Second point, there is no change in volume, means when component A, 100 ml of component A is mixed with 100 ml of component B, and when both are mixed, so therefore there is no change in volume. So, for example, I will show here, look here, it is component A, and it is component B, A and B. When this A and B, so it is B. When both, that is A and B, 100 ml of this are mixed, it gives 200 ml of A plus B. So, A plus B, there is no change in volume. Look here, 100 ml of A is taken and 100 ml of B is taken and both are mixed, and therefore it becomes 200 ml, there is no change in volume. And heat is also not evolved. So what is the reason and why it is called as ideal solution? So the ideal behavior of the solution can be explained by considering the two components. Look here, when this A and B, the two components are there. So here it is a pure component, it is also a pure component, it is called as a mixture, A plus B. When in a pure component, the intramolecular attractive force between A, the intramolecular attractive force between A and the intramolecular attractive force between B are always same. The intramolecular attractive forces between A and between this B are always the same. And when these two components, equal volumes of these two components are mixed, so here A plus B is added, are mixed. So therefore, the intramolecular attractive force between this AB is also same. So it is also same, means there is no change in the intramolecular attractive force when both the components are mixed. There is no change in the intramolecular force of attraction or intramolecular interaction when both the components are mixed, and such solutions are called as ideal solutions. So it is the characteristics of ideal solution. So look here, in case of ideal solution, when the two components A and B are mixed, there is no change in the enthalpy. Enthalpy means heat content of the system. So heat is neither absorbed, heat is nor evolved. Neither heat is evolved nor heat is absorbed. So there is no change in enthalpy. Neither heat is evolved nor heat is absorbed. So the heat is not evolved or absorbed. So then second one, there is no change in volume when both the components are mixed. There is no change in volume when both the components are mixed. That is delta V mix is equal to 0. So here 100 ml of this, it gives exactly 200 ml, there is no change in volume. So delta V mix is equal to 0. Delta V mix is equal to 0 means not 0 volume, so there is no change in volume. And here heat is neither absorbed, heat is neither evolved or neither absorbed. Here delta V mix, delta H mix is equal to 0. There is no change in enthalpy, there is no change in volume. Then I explained already the reason. So here I have given the reason. When a component A, the intramolecular attractive force between the component AA in the pure state and the component B in the pure state, the intramolecular attractive force between BB is the same, and when both the components are mixed, and therefore here the intramolecular attractive force between A and B is also same. So therefore, when the intramolecular attractive force between the pure component, that is solvent and solute, is always the same when both the components are mixed, then therefore the such solutions are called as ideal solutions. So third one I will write here. Look here, third one. So third one, the ideal behavior of the solution. Can be explained on the basis of Raoult's law. The ideal behavior of solution can be explained by considering the two components. Explained by considering two components. The two components are, that is A and B. So here we have to consider two components by considering the two components. When the component A, when the pure component A is mixed with another pure component B. Look here students, when the pure component A is mixed with another pure component B, so there is no change in the intramolecular attractive forces between the pure component AA, BB and its a mixture AB. Look here. The ideal behavior of the solution can be explained by considering the two components A and B. So when the pure component A is mixed with another pure component B, there is no change in intramolecular attractive force, or there is no change in intramolecular interactions, intramolecular attractive forces between the pure component AA, BB and its mixture is always the same. So students, it is important one, and due to this reason the such solutions are called as ideal solutions, and therefore there is no change in volume, there is no change in heat, the enthalpy remains same. It is neither evolved nor absorbed. Such solutions are called as ideal solutions. Actually, there is no perfect and ideal gas. So some solutions are there which are nearly, that is ideal. The best example is benzene and toluene. The best example is benzene and toluene. It is the best example, benzene and toluene. And the second example is, you may also write another example. So N-heptane and N-hexene, N-heptane and N-hexene. So you may also write this. And bromoethane, third example, you may write bromoethane and chloroethane. So, these are the examples for ideal solutions. You may also write chlorobenzene and bromobenzene. You may also write chlorobenzene and so students, so these are called as characteristic properties of ideal solution. So remember once again, ideal solutions are those which obeys Raoult's law at all concentrations. And here, what are the characteristic properties? So in case of ideal solution, when the two components A and B are mixed, so there is no change in enthalpy. Delta H mix is 0. Heat is neither evolved or absorbed. And there is no change in volume when both the components are mixed. So exactly 200 ml of that is mixture C is there. And what is the reason behind this? So the ideal behavior of the solution can be explained by considering the two examples are two components A and B. So that is I have explained here already. So now these are the examples here. And let us see that is what are non-ideal solutions. What are non-ideal solutions? Look here students. What are non-ideal solutions? Second one, non-ideal solutions. The solutions which do not obey Raoult's law at all concentration range is called as non-ideal solution. The solutions which do not obey Raoult's law at all concentration range or wide range of concentration are called as non-ideal solutions. Are called as non-ideal solutions. Look here students, which do not obey Raoult's law at all concentration range or wide concentration or a wide range of concentration. So these are called as non-ideal solutions. And here in non-ideal solutions, the vapor pressure of the solutions either may be higher or lower. The vapor pressure of such solutions are higher or lower. Vapor pressure of such solutions are either higher or lower than their solutions, higher or lower than their solutions, or then lower than that predicted by Raoult's, that predicted by Raoult's or the predicted by Raoult's law. So these are called as non-ideal solution. It is for 2 marks. What are non-ideal solution? So here you may also write that is P total is equal to not equal, does not obey P1 not x1 plus P2 not x2. You may also write this. So here it does not obey Raoult's law at all concentration or at a wide range of concentration. And here the vapor pressure of such solutions either they may be higher or they may be lower as predicted by Raoult's. So, here these non-ideal solutions further classified into two types depending upon their vapor pressure. And if the vapor pressure is more, it shows positive deviation, and if the vapor pressure is low, then it shows negative deviation. So, students, let us see how these are classified. Classification of non-ideal solutions. Look here, there are two types of non-ideal solutions. There are two types of non-ideal solutions. So, here there are two types of non-ideal solutions. Based on their vapor pressure. These are classified into two types. One is that is there are two types of non-ideal solution based on their vapor pressure. Non-ideal solutions showing positive deviation from Raoult's law, non-ideal solution showing positive deviation from Raoult's law. So, here the vapor pressure is high. So, the vapor pressure is high. So, here if the vapor pressure is higher, then this shows a positive deviation. The vapor pressure is high. And second one, non-ideal solutions showing negative deviations from Raoult's law. Negative deviation from Raoult's law. So, the vapor pressure is low. Look here students, if the vapor pressure is lower, then the solution shows a negative deviation. If the vapor pressure is high, the solution shows a positive deviation. These two classification, and these two are also important. They may ask in the examination, so distinguish between non-ideal solution showing positive deviation as well as a negative deviation. It is for 2 marks or 3 marks. If you write 2 difference, then you will get 2 marks. If you write 3 difference, then you will get 3 marks. So, 2 marks and 3 marks question may ask. So, here let us see first one, non-ideal solutions showing positive deviation from Raoult's law, and these are having higher vapor pressure, and non-ideal solution showing negative deviation, these are having lower vapor pressure. Based on the vapor pressure, so the non-ideal solutions are classified into two types. Then, what are the characteristics? Look here, non-ideal solutions showing positive deviation from Raoult's law. So, it is also called as a characteristic properties. What are the characteristics here? So, number one, so here the solutions for which the total vapor pressure is higher than that predicted by Raoult's law are given by ideal solution. The solutions, number one, for which the vapor pressure is higher than predicted by Raoult's law or than the ideal solution. Than the ideal solutions. So, it may be also represented by symbolically. So like this. So here P total is greater than P1 naught x1 plus P2 naught x2. So here the solutions for which the vapor pressure is higher than that of the ideal solution. P total is greater than P1 naught x1 plus P2 naught x2. So then second one, when two components are mixed, so here the volume increases, it shows positive deviation. And the third one, there is no change in enthalpy when both the components are mixed. So that's why it is called as a positive deviation. So here why it happens? So I will write here, in non-ideal solution, or in this case, so in this case means that is here, in this case the intramolecular attractive force, the intramolecular attractive forces or intramolecular interactions, intramolecular interactive forces between you may write first pure component or you may write first the mixture. So between intramolecular attractive forces and intramolecular attractions between the mixture AB is weaker. AB is weaker than the intramolecular attractive forces of pure component AA or BB. Look here students, here in this case the intramolecular attractive forces between the mixture AB is weaker than the intramolecular attractive force between the pure component AA or BB. Means what? So I will show here, So look here component A, and here it has a intramolecular attractive forces AA, and here component, it is component B like this, it is component B, it is taken 100 ml, look here, both are 100 ml, and when both the components are mixed, look here, when the components are mixed, that is AB, so it is AB, when the components are mixed, it is a mixture and both are pure component. When it is mixed, look here, the intramolecular attractive force between AB is less or AB is weak. The intramolecular attractive force or intramolecular attraction between A and B is weak, less as compared to the intramolecular force of attraction between AA and BB. So here it is weak and here that is it is weak. So therefore the molecules A and B, they stay away from each other, hence the volume increases. The molecules, that is here the intramolecular force of attraction weaker, and due to this reason, so they remain stay or they remains, that is away from each other, and therefore the volume increases. So here when 100 ml this mixed and it gives, that is 200.4 ml. Look here students, 200.4 ml or 200.5 ml. So the same thing is happened here. Look here, when a mixture of, look here, I will take here example, ethyl alcohol and acetone. So 100 ml, and when this ethyl alcohol and this acetone are mixed, ethyl alcohol and acetone are mixed. Look here, ethyl alcohol and acetone are mixed, so it is here it becomes 200.4 or that is 3 to 400, 200.4 ml. So 0.4 ml increases here. Why it increases? Because when both ethyl alcohol and estones are mixed, so therefore the intramolecular attraction or intramolecular attractive force between ethyl alcohol and estone is weak or less, and the molecules ethyl alcohol and estone stay away from each other, and hence the volume increases, and here the volume increases. So therefore, in this non-ideal solution showing positive deviation, there is increase in volume. The volume increases. Why the volume increases? So here I will explain. Look here students, it is alcohol. It is alcohol. Alcohol is having a strong hydrogen bond. It is having a strong hydrogen bond. I will write here ROH, ROH. Look here, it is alcohol. Alcohol is represented by ROH. So there is a strong hydrogen bond between hydrogen, this hydrogen and oxygen. So there is a strong hydrogen bond. ROH, ROH, ROH. So strong hydrogen bond. And the vapor pressure of ethyl alcohol is less. So when acetone is added, CH3CO, CH3, acetone is added to this. So therefore, acetone breaks some of the hydrogen bond in alcohol. Acetone breaks some of the hydrogen bond in alcohol, and it forms a compound, and hence the intramolecular attractive force decreases and the vapor pressure increases. Remember this one. So how the reaction takes place? I will write here. Look here, I will write ROH plus, I will write acetone here. I will write acetone here. Look here, CH3, C double bond O, CH3, acetone, R1, R2. Look here, it is acetone, it is acetone. When acetone is mixed with alcohol, I will write alcohol like this. Look here students, it is alcohol. So when acetone is mixed with alcohol, so the hydrogen bond between the alcohols are broken, broken by this acetone, and then it combines with it. Look here, and then it forms R1C, it forms R1C O H R2, and here it is OR. Look here students, acetone when combines with alcohol, it forms hemiacetal. It is called as hemiacetal. It is called as hemiacetal. So here some of the hydrogen bonds are broken, and then acetone enter into this alcohol, and the intramolecular attractive force decreases and the vapor pressure increases. It is the reason here. I think it is clear to you all. I have taken both A and B component and also the example of ethyl alcohol and acetone, and here the volume increases, and here remember enthalpy, that is it becomes positive. Heat is absorbed. Heat is absorbed because the intramolecular attractive force is less. It is weak, and due to this reason heat is absorbed. So endothermic reaction takes place. So then similarly we may also write for carbon disulfide and acetone. So look here, third point. So third point you may write simply, that is there is increase in volume. Increase in volume when both the components A and B are mixed, that is AB, that that is V mix is equal to positive. The volume increases. There is increase in volume when both the components are mixed, as I already explained why the volume increases. Due to that is a weaker intermolecular attraction between this AB, the molecules stay away from each other and they maintain the distance between these two, and therefore the volume increases. And fourth one, there is here heat is evolved or heat is absorbed. Heat is absorbed. Heat is absorbed when both the components are mixed. That is delta H mix is equal to positive. It is endothermic reaction. Endothermic reaction. So, students, you have to write these 4 characteristic properties. The solution for which the vapor pressure is higher than the ideal solution, and in this case the intermolecular attractive forces between this mixture AB is weaker than the intermolecular attractive force of pure component A and BB. So, as I already explained here. And then fourth one, there is increase in volume when both the components are mixed. V mix is positive and heat is absorbed when both the components are mixed, that is delta H mix is equal to positive. It is an endothermic reaction. So, you may write examples here. You may write example. You may write example here. The first example is here acetone and ethanol. Ethanol, as I have given, that is example acetone and ethanol, plus second one water and ethanol, and water and methanol. Water and methanol. So, you may write even acetone and benzene. Acetone and benzene. So, these are the examples. You may also write carbon tetrachloride and benzene also. CCl4 plus C6H6. So, it is about non-ideal solution. So, it carries 3 marks. It carries 3 marks. Write the characteristic properties of non-ideal solutions and remember these examples. And non-ideal solution showing negative deviation exactly opposite to this. Very simple. Look here, non-ideal solutions showing positive deviation. And here students, you may also plot a graph. Look here, for non-ideal solution showing positive deviation, it is a graphical representation. So, here we know that when a graph is plotted, vapor pressure against mole fraction. Look here. So, here it is ideal solution. It is a ideal solution. And here the first one, non-ideal solution showing positive deviation. Non-ideal solution, it is ideal solution. Non-ideal solution showing positive deviation. Look here, very slight that is change. Look here, it is called as positive deviation. So, here you may write that is same thing. So, x1 is equal to 1, x1 is equal to 1 and x2 is equal to 0, or that is here you may write that is in a reverse manner also, x1 is equal to 0 and x2 is equal to 1, and then x2 is equal to 0 and x1 is equal to that is 1, and here the two components are there, P1 and P2. It is called as a positive deviation. So here it is a P total. Same, just draw the line, positive, show positive deviation. Then second one, non-ideal solutions. Non-ideal solutions showing negative deviations from Rolle's law. So again exactly opposite to this. Here the solution for which the total vapor pressure is the solutions for which the total vapor pressure is lower. The total vapor pressure is lower than that of ideal solutions. So you may also write P total here. P total, it is less than, we will write less than P1 naught x1 plus P2 naught x2. Then second same, in this solution, look here, in this solution, the intramolecular force of attraction between the mixture AB is stronger as compared to the intramolecular force of attraction between the pure component AA or BB or solvent or solute. So therefore, when the intramolecular attractive force is stronger, the molecules are very close to each other. And hence the volume decreases. And therefore, due to higher, that is stronger intramolecular force of attraction, heat is evolved. It is an exothermic reaction. Look here students, here I will take that is in one beaker, so I will take water, and in another beaker, so I will take HCl. So, or you may take that is water HCl, or you may take that is acetone and chloroform and acetone or aniline. So look here, it is 100 ml, it is also 100 ml. So here, if you call it as component A, if you call it as component B, and when both the components are mixed, so it is water plus HCl, so it is AB. Look here, 100 ml, and here it becomes 99.9, that is 91 ml. The volume decreases slightly because the intramolecular attractive force between AB is stronger. The intramolecular force of attraction between AB is stronger. The molecules stay very close to each other, and therefore the volume decreases and heat is evolved. It is an exothermic reaction. So remember, so the intramolecular force of attraction between AB is greater than the AA or that is BB. So therefore the volume increases. So that is here, the volume that is here negative becomes, that is decreases 99.9, and heat is evolved. So let us see that is here what happens. Then the next characteristic property in this solution, when both the components are mixed, in this solution the intramolecular attractive forces between AB is stronger as compared to the intramolecular intermolecular force of attraction AB is stronger as compared to the intermolecular force of attraction between the pure components AA or BB. So, in this solution, the intermolecular attractive force between AB is stronger as compared to the intermolecular force of attraction between the pure component AA and BB. So, here hence the volume decreases. Volume decreases. The molecules stay very close to each other. The molecules stay very close to each other, and therefore, here I will write third one. When both the components A and B are mixed, the volume of the mixture decreases. That is, delta V mix is negative, or delta V mix is negative. So, it is here delta V mix, that is volume decreases. Remember, it is negative. And when both the components are mixed, heat is evolved. It is an exothermic reaction. It is an exothermic reaction. That is, delta H mix is equal to negative. Heat is evolved. It is an exothermic reaction. Remember, students, here it is endothermic reaction. You may write example: water plus HCl, water plus HNO3. You may write organic acetone plus aniline. Acetone plus aniline, and you may write chloroform plus benzene. Chloroform plus benzene. Many examples are there. So, here about non-ideal solution which are showing negative deviation. So, students, let us see that is here. Again, that is we can represent the graphical method. Here graphical method means again here when the graph is plotted, mole fraction against vapor pressure against mole fraction, you will get like this. It is ideal solution. And negative deviation means like this. Again, you may write that is this x1 is equal to, so x1 is equal to 0 and x2 is equal to 1 and x1 is equal to 1 and x2 is equal to 0, like this, that is you may write. You may take any component on any side. Maybe that is x1 that is equal to 1 or x2 is equal to 1, any component on any side. So, here let us see the difference between these two. So, what is the difference between these two? So, I will explain one by one. Look here, students. Here, distinguish between ideal and non-ideal solution. First, 3 marks question. First, you have to write that is it obeys ideal solution, obeys Rod's law at all range of concentration, and it does not obey Rod's law at all concentration range. And second one, neither heat is evolved nor heat is absorbed during the dissolution or mixing, delta H mix is equal to 0. And here heat may be evolved or absorbed during the dissolution, delta H mix is not equal to 0. It may be negative or it may be positive. And then there is no change in volume when both the components are mixed. Delta H mix, delta V mix is equal to 0. So, volume of the mixture may increases or decreases. It depends upon its nature. And then the intermolecular attractive forces between the pure component and mixture are same. So, therefore, here P total is equal to P1 naught x1 plus P2 naught x2. And here the intermolecular attractive forces are not same between AA and BB, and this, that is AB. So, therefore, P total is not equal to P1 naught x1 plus P2 naught x2. So, here what is the difference between non-ideal solution showing positive deviation and negative deviation? Look here, heat is absorbed during the dissolution, H mix is positive. So, heat is absorbed from the surrounding because intermolecular attractive force between AB is less, weaker, and volume increases when both the components are mixed. So, here due to weaker intermolecular attractive forces between the two components, that is A and B. So, therefore, here the molecules stay away from each other, and attractive force between AB is weaker than pure component AA and BB, and then P total is greater than, so P1 naught x1 and P2 and x2. So, because the upper pressure increases, it forms minimum boiling point azeotrope. I will explain later. And again, heat is evolved during the dissolution, H mix is equal to negative, and volume decreases when both the components are mixed. So, here volume decreases and here volume increases. So, here it is volume decreases, and then attractive force between AB is stronger than the pure component AA or BB. So, P total, that is here P total is less than P1 naught x1 and P2 naught x2. So, it forms a maximum boiling point azeotropes, and here it is the difference, students. Look here, this is the difference. So, here they may ask, that is for this, that is 3 marks, distinguish between ideal and non-ideal solution, or for this 3 marks, distinguish between non-ideal and a solution showing positive deviation and non-ideal solution showing a negative deviation. So, students, in our next video, we will discuss about the azeotropic mixture. So, thank you.